one would take the snap if the number is more than 25. Okay.
Okay.
So there is actually I have done the auto admit, so there is no need to ask anyone to join. So they directly join to class. So the number at present 25. So we will check whether it should be more. As first lecture is delayed due to some technical issues, so it is better way to start our regular lecture. And when the number is going at now 27, so take Ankita the screenshot at meanwhile the number when it is rises, then 27, 29, and if it is going above 30. But as far as the strength is concerned, now it is why it is less, we have to think over it. Okay, can you see the PPT?
Yes, sir.
Okay. Okay, so on last lecture we have started completed the one group disconnection, and now we will move towards the two group disconnection. Meanwhile the surprise test, that is online exam, is completed. Probably in the last week also, as the college will decide, then also there will be a one kind of test. So be prepared. You should do your work regularly. So in two group disconnection is nothing but in that case we will see the number of two groups are present, and their position, on that position they are be further classified as 1 1 1 2 1 3 1 4 1 5 1 6 difunctionalized compounds. So we start with 1 1 difunctionalized compound. So 1 1 difunctionalized compound is nothing but when the two heteroatom or two functional groups are joined to one and the same carbon atom. So this carbon atom actually undergo oxidation to form a carbonyl group, and then molecule made from carbonyl compounds, and second is always nucleophile. So such kind of disconnection is always observed when the two functional groups are attached to the one and the same carbon atom. So in this case, simply we can represent the two functional group like X and Y. When they are joined to one and the same carbon atom, it is called 1 1 difunctionalized compound, and generally it is converted to the carbonyl group. And the two function group like X and Y, they are as a HX and XY. So if you take simple example, that is cyanohydrine. So in the disconnection of cyanohydrine compound, in which two functional groups like hydroxyl and cyanide are attached to one and the same carbon atom, and that's why it is called as 1 1 difunctionalized compound. And here, when the lone pair of electron of oxygen form a double bond over here, cyanide is removed, and that's why cyanide get negative charge and this oxygen get positive charge. And generally it can get corresponding acetone, and there is HCN. And it is a very simple reaction, that is potassium cyanide in presence of its acidic medium. It reacts with acetone to form corresponding cyanohydrine. So similarly, when we can see the another kind of retrosynthesis compound, that is cyclohexanol, which having one amino ethyl group and hydroxyl group are now. So that is nothing but this pyrocarbon, that is the carbon which having the four different, that is the two hydroxyl, one hydroxyl and one amino ethyl group is there. Here we have observed the two functional groups are attached to the one and the same carbon. Then how we can disconnect? Now we know that this CH2NH2 is not a good disconnect synthon, and that's why instead of breaking this, so we have not disconnect bond here. What will happen if lone pair of electron of oxygen is attacked over here? It can form double bond. No doubt, it is very easy to form cyclohexanone, but this CH2 get negative charge. It's not a good synthon. We remember. Otherwise, we can disconnect over here. So there is also possibility. So we have to disconnect either one bond. Oxygen is more electronegative as compared to carbon, and that's why it can form a carbonyl group. And here the disconnection is always towards this alkyl group. But this amino methyl carbanion is formed, it is not a good synthon. And that's why instead of this disconnection of carbon carbon bond, that is 1 1 carbon carbon disconnection, we use functional group interconversion. And when we can use functional group interconversion, this CH2NH2, it is obtained by the hydrogenation of this cyanide group. And that's why the functional group interconversion, when we can carry it out, here we can obtain cyano. And now once we can get cyanohydrin like moiety, then it is easily removed to form corresponding carbonyl and cyanide. Okay, so do you understand why we can move towards functional group interconversion instead of carbon carbon disconnection?
Yes.
Yes or no?
Yes, sir.
Yeah, so that is very important part, that always you must think along with disconnection, functional group interconversion is also very important. You might have to think like that only. Okay, so it is very simple reaction that the starting material cyclohexanone is easily available. Potassium cyanide in presence of acid, we can get cyanohydrin, which undergo reduction, we can get corresponding CH2NH2. Okay, so in this way we can obtain corresponding target molecule. Now, as it is a 1 1 difunctionalized compound, such kind of acetal or ketal formation is always there. So this carbon atom, they having two methoxy groups. So it is called 1 1 difunctionalized disconnection. And here there are two carbon oxygen bond is undergo disconnection, and they can prefer towards aldehyde, and methanol are there. Okay, so generally when we can carry out such kind of reaction, two equivalent aldehyde react with two equivalent of methanol, we can get corresponding acetal. So protection is there, and in this case then this proton is acidic one. So it is very simple reaction, that is aldehyde react with one equivalent of methanol, there is hydroxyl and O methoxy, then further undergo methylation, and we can get corresponding target molecule. So in this way, when there are two functional groups are attached to one and the same carbon atom, it may be same, it may be different, then the disconnection is carried out by in this way. Now, when such kind of 1 1 difunctional compound is cyclic one, like this one, then how we have to disconnect? So in this case, 1 1 difunctionalize is with respect to these two, not the rest of these. So these are alkyl chain. Now there are two oxygen atoms are there. Here also there are two oxygen atom, and one R and one hydrogen is there, and that's why we have considered aldehyde. But in this case, that hydrogen is replaced by this alkyl chain, and that's why instead of aldehyde, here we can get ketone. So 1 1 difunctionalized disconnection is along with these two, so we can get corresponding ketone, and we can get, what is the name of this? 1 2 what is the name? Ethylene
Diol.
glycol or 1 2 diol. Okay, so here how the, so if you observe, this is a structure, when once you can observe, then we are thinking it is very difficult, but it is very easy to disconnect, and here we can get 1 2 diol. So when ketone in presence of acidic medium undergo reaction with ethylene glycol, we can get such kind of protection. Okay, then similar kind of one more reaction is there, that is amino acids. So in the amino acids, we have observed there is a symmetric center or carbon that having four different function groups are there, in which major is NH2 and COH, right? So when we can carry out functional group interconversion, because when we can try to disconnect this, either this bond, it is very difficult to form the suitable synthon, and that's why we can prefer functional group interconversion. When we can carry out functional group interconversion, we know that COH group is obtained from cyanide, because cyanide undergo hydrolysis to get corresponding COH. Now, once we can get corresponding CN, then always aldehyde, and when we can break this lone pair of electron, this bond is removed, because here in this case we have observed oxygen, like that here the lone pair of electron of the nitrogen is used, so it can form corresponding imine at the intermediate, and cyanide is removed. And we know that imine is obtained from aldehyde and ammonia, so that is nothing but Here the corresponding synthon or synthetic equivalents are aldehyde, ammonia and cyanide. So in this way the synthetic equivalents are nothing but these three, and it is a very simple reaction. That is, which reaction is this one? Staker synthesis. That is aldehyde, ammonia and potassium cyanide or hydrogen cyanide. When it undergo reaction, we can get corresponding cyanoamines, and these cyanoamines undergo hydrolysis, we can get corresponding amino acids. So in this way the two functional groups, when they are attached to one and the same carbon atom, we can disconnect by such a simple way. Now we will see some very important natural fragrance, that is like perfume. If you observe its structure, it is a very simple pH CH2 C CH3 CH3OH. So in this case, these two functional group, that is hydroxyl and this alkyl of benzyl chain, they are attached to one and the same carbon atom, and that's why they are coming in one difunctionalized category. Now when we can disconnect this, what will happen? We can get pH CH2 minus, and here is positive charge, and we know that when it is positive charge, always it is converted to corresponding acetone, and when the pH CH2 is there, it corresponds to Grignard reagent.
Reagent.
So it is very simple, disconnection is there, and that's why we can prefer the benzyl chloride or benzyl bromide. So generally we can prefer benzyl chloride as far as the fumes and smell is concerned, uh, because it is when we can use, then we have to take the precaution always. It is irritating to the eyes are there, and that's why we have to take precaution when we can use this one. Then it is a very simple reaction. This benzyl chloride react with magnesium in presence of dry ether, which undergo corresponding Grignard reagent. So this Grignard reagent react with acetone, we have obtained tertiary alcohol. So in this way, the lilac perfume can be synthesized by using the Grignard reagent. Now, when such kind of functional groups are there, then we have observed, so this is equivalent to methyl groups are there, and that's why it is very easy. But when they are non-equivalent, again it is a fruity peony perfume. So if you observe, there are three different alkyl groups are there, A, B and C. Okay, so we have to check at which position we can disconnect, whether this is A is correct, whether the B is correct or C is correct. Okay, so you have to think that which is the most preferable way to disconnect such kind of three different uh, alkyl chain are attached to the, so it is a chiral center, and that's why such kind of natural compounds are available in the nature, and we have to isolate it. We can get a number of isomers are also there, and that's why we have to remove that one. And when we can synthesize this kind of compound, always we can get a racemic mixture in our regular laboratory, and we have to separate out by using the column chromatography or HPLC. So in this way, here there are three different kind of disconnections are there, which is the correct one. For more simplify to you, I prefer C. Okay, why? Anyone? Okay, anyone know? Yes or no? Are yes or no? Okay, are you there or you are just silent?
Yes, sir.
But just say a yes or no. That is,
Yes,
I am
sir.
not asking such questions. I'm just saying that whether you know anything, then you can say yes, or you didn't know, you can say the no. That doesn't matter. Okay, so no, because when we have to think over this, such kind of two methyl groups are there, that is two carbon chain is there, so it is very difficult to form Grignard reagent. In this case, what will happen? There is pH, such a long chain we have to prepare, right? And when we can take starting material and we can disconnect over here, then further disconnections are there. Here, if you observe, such kind of compound it undergo further disconnection. How it can be carried out further disconnection? This, if we say that this is ketone group and this is pH, so this is 1 and 2, and always when we can form such kind of group, we have to prepare double bond over here, be remember. And once we can form double bond, what will happen? We have to disconnect over here, because normal disconnection when we can try without forming a double bond, then there is possibility that the polyalkylation is takes place on either side. Okay, and that's why we have to use which kind of reaction? Anyone can say? In retro also we have seen that reaction, very first enamine reaction, be remember, right? So to avoid the polyalkylation on both the side, we have to use enamine reaction, because particularly they can give alkylation,
Yes,
that
sir.
is monoalkylation. Okay, that is one out the way. Okay, now if you use this C route, then what is the step? That is Grignard reagent react with this, we can get this product. So when we can disconnect this, this is ethyl magnesium bromide, it is okay, and we can obtain this. But the question is how it is obtained. That is very very important question, and that's why I've given the question mark, because rest having a certain problem that I have just discussed. The polyalkylation more than two products can be obtained, but only C route is there. Then for this, how we can carry out the reaction? Okay. So in this case, when we can carry out aldol condensation, we have obtained alpha beta unsaturated ketone. Then it undergo reduction, we have obtained this product, right? So this compound can be synthesized by forming double bond, and when we can break this, always we can get aldehyde and ketone. And when we can carry out such kind of reaction, we have obtained the target molecule. So did you understand how this reaction is carried out?
Yes, sir.
Yeah. So it is very easy. But you may think like that if there is such kind of situation is there, there is possibility to form alpha beta unsaturated. You alpha beta unsaturated is not formed very easily, even though it looks like very simple, but it not work like that. And that's why always you can carry out such a reaction that always get single product, not more than one product formation possibility, so that you have to check. Okay, now we can see one more example. In this case also there are two groups are there. One is hydroxyl, and such kind of alkyl chain is there, and one alkane group is there, or alkyl group is there and alkane group is there. So that is nothing but again there is two possibility of the disconnection, because hydroxyl group is there, so always we preferred the carbon bond next to the hydroxyl is always disconnect, so there is either possibility A and B. Now the question is arises which is the correct one. Okay, so when we can see such kind of disconnection A and B, what will happen when we can disconnect B? We can get aldehyde over here, that is nothing but CH2 CH2 CHO and vinyl bromide, and we can vinyl Grignard reagent. This is one of the way. What's about second way? When we can disconnect A, what will happen? We can get here positive charge, here is negative charge. So that is nothing but here we can get alpha beta unsaturated aldehyde, and second thing that here we can get negative charge that corresponds to Grignard reagent. Again, this Grignard reagent is obtained from halogen, and this CS2 CS2OH which is obtained from hydroxyl. Okay. So in this case, when this hydroxyl group undergo halogenation by using thionyl chloride or thionyl bromide along with sodium iodide, we can get iodine, then it react with Grignard reagent followed by reaction with aldehyde, because alpha beta unsaturated aldehyde is there, and that can gives corresponding target molecule. So in this way we can get a target molecule. Also, there is possibility that when we can try to carry out such kind of formation, if you observe stereochemistry over here, what is your thinking about this stereochemistry? Anyone? It is alkene, right? If it is alkene, whether it is cis or trans,
Cis.
cis,
Cis.
then how the cis is obtained from
Cis.
alkyne? So anyone may start with this alkyne over here, disconnect this, and carry out the reaction. So that is also one of the way to carry out the synthesis. Okay. Now in the one disconnection, we can take one more example. So here we can take such kind of retro compound in which there is methyl group, this is alkyl chain, and this is oxygen, because it is connected, and that's why there is possibility that we have to disconnect over here. And when once we can disconnect over here, we can obtain hydroxyl and corresponding COH. So if you observe, this is a type of alcohol, this is type of lactone. When we can break, so that converted to the, so actually whole structure is a lactone, but when we can disconnect over here, we can obtain alcohol as well as acid. So this is one carbon carbon disconnection as compared to the alkyl chain is considered. And in between that, when we can disconnect over here, then we can get 1 2 3. So it is a 1 3 difunctionalized compound is also formed once we can disconnect over here, because always there is lactone ring, so we have to disconnect here. No doubt there are so many ways are also there, so we have to always identify the functional group and pattern that we already mentioned. So if there is lactone, then always we can obtain from a lactone from alcohol and acid, and that's why we can prefer the such kind of disconnection between oxygen and carbonyl most. So no doubt there are so many ways are there to disconnect 1 2 3 4 5, but we have to disconnect over here only, right? So that is very important. And once we can obtain this, then we can carry out further reaction. Okay. So once we can disconnect over here electronization, we can get hydroxyl group and acid, and we know that this is obtained from cyanide. And when there is such kind of ring is the single bond is there, and there is no any kind of chance to form a disconnect, at that time always we can prefer double bond or triple bond, because its reduction is very easy at the later stage. So the reduction is carried out, we can get triple bond, and then it is very easy to disconnect. And when we can remove this one, we have to obtain such kind of synthetic equivalent. Okay, and then we have remove this. So COH is nothing but it is CO2. Triple bond is there. We have to disconnect this. That is acetylene, and we can get corresponding butyraldehyde. So once alkene is installed, then the rest of retrosynthesis is very easy, because on either side we have to add sodium NNH2, and when we can add butyraldehyde, we easily obtain this one. And then again we have to add CO2 over here. So it is very simple reaction, that is acetylene react with NNH2 in presence of butyraldehyde, we have obtained this intermediate. And then it react with N-butyl lithium in presence of dry CO2 is commonly used over here, and in acidic medium we have obtained corresponding acid. Now we have to convert this into the single bond. So triple bond is undergo reduction to get single bond, and once it can form a single bond, then it is easily rotate. Okay, so its planarity has been disturbed and it coming over here. So COH and OH are very much closer, and they can easily undergo cyclization to obtain a target molecule. So did you understand how the target molecule like lactone can be disconnect and synthesize?
Yes,
Yes
sir.
or no? So it is very easy, because even though it look like that, you can
Sir.
prefer acetylene. Okay, so such a kind of reactions can be carried out. So it is a very simple disconnection. Once you can form acetylene, then it is very easy. Now we'll move towards 1,2 difunctionalized compound. So this is 1,1. Now we can move towards 1,2 difunctionalized. So 1,2 difunctionalized is nothing but the compounds which contain two heteroatoms which are adjacent carbon atoms. So they are at position 1 and 2. So they are not attached to one and the same carbon atom, but they are attached to the corresponding adjacent carbon atoms. So generally, when we can see the two functional groups, hydroxyl group is always there, nitrogen is there, sulfur is there. So heteroatom like oxygen, nitrogen, and sulfur, they are attached to the adjacent carbon atom. It is called 1,2 difunctionalized compounds. So when we can see such kind of general structure of 1,2 difunctionalized, this is carbon number 1, this is carbon number 2, and they having different functional group. So it may be same or it may be different. That's why we have mentioned over here X. X may be NH2, X may be OH, it may be alkoxy, or it may be thioalkyl. So such kind of groups are there at 1 and 2 positions. So it is called as 1,2 difunctionalized. And always remember, when there is hydroxyl group, we should disconnect between the heteroatom and carbon number 2. So why? Because whatever the synthons are obtained is X minus and A2 plus, that is acceptor. And always be remember that when the lone pair of electron of oxygen is available at carbon number 1 and carbon number 2 get positive, so lone pair of electron is attack over here and we can get corresponding epoxide. So this is very easy to remember the epoxide. So in this way, the lone pair of electron of oxygen attack over this carbocation and it can form corresponding more stable epoxide. And it is electron deficient, so the nucleophile can easily attack over here. So any nucleophile, that is RS minus, RNH2, or R2NH, or alkoxy group. So any act as a nucleophile. So did you understand? Always in 1,2 difunctionalized compound, hydroxyl group is there, then the carbon number 2 and that functional group is always removed, so we can get corresponding epoxide. So if you observe this lone pair of electron of secondary amine attack over epoxide, ring get open, and here we can get corresponding alkoxy group. So in presence of acidic medium, they picks up the proton. This alkoxide picks up the proton from this amino, that is ammonium salt, and it neutralizes the tertiary amine. So in this way, such kind of target molecule can be synthesized. So any target. So it is not like that only. So that we can use any kind of two different functional group. Now, always it is not that this carbon number 2 having one functional group and hydrogen. So there is also possibility that side chain is also there. So again, we have to prefer such kind of position. We have to disconnect that X. The alkyl chain is not towards only carbon number 2. There is also possibility that there is a side chain in the carbon number 1 also. So on either side, any side chain is there. Be remember, always we have to disconnect carbon number 2 and X, not any alkyl chain. Okay, did you understand? So in 1,2 difunctionalized compound,
Yes, sir.
always remove the other functional group other than the side chain. So in this way, we have to obtain such kind of epoxides, different epoxides, and any kind of nucleophile is there, because always here positive charge and negative charge. So this negative charge is act as a nucleophile, and so it can attack on the epoxide and we can get the target molecule. So any target molecule can be synthesized when such kind of function groups are present on 1 and 2 position. Okay, so did you understand the basic thing? Yes or no?
Yes.
Okay, so this is for hydroxyl group, because in generally 1 2 position hydroxyl group is there. Now when carbonyl group is there, what will happen? So in this case, instead of hydroxyl, when the carbonyl group is there, so it is called as 1 2. So one is halogen X, other is carbonyl. So always we can break again here, that is acceptor 2. And once we can get here, this bromine and halogen is there. Okay, so it is in all keto when we can break, we can get corresponding ketone. And when we can carry out the bromination by using acetic acid, that is the side chain, bromination is always there preferred, and this is a mild brominating conditions are there, and that's why it can give corresponding alpha halo compounds. Okay, so when we can generalize this, any nucleophile is there, 1 and 2 position, that is 1 to di X. What this indicate? There are two functional group at 1 and 2 position, and we can disconnect this always. So we can get A2 synthon, that is acceptor at position 2, and the reagent is always preferred to the such kind of chain having the halogen group. So bromine and chlorines are commonly used, and then nucleophile can attack over here. We will take some examples directly. In this case, we will take a muscle relaxant drug is there, that is phenyldimidol. So in phenyramidol, there are two functional groups are there. One is hydroxyl, second is secondary amine. So always we preferred oxygen and nitrogen is there. So oxygen is more electronegative, and that's why we can break the bond with respect to the other functional group. We know that when lone pair of electron, the positive charge is there and negative charge on NH2, so we can get corresponding to aminopyridine and corresponding styrene oxide. So here we can get positive charge, that is synthon, and here we can get negative charge, that is 2-aminopyridine is there, that is synthetic equivalent for that, and here we can get the styrene oxide. Okay, so it is very simple reaction, even though it looks like such kind of molecule, but it is very simple, that is 2-aminopyridine is easily available, and it react with styrene oxide is also easily available. In pens of base, when we can carry out reaction, we obtain such kind of target molecule. Similarly, just instead of phenyl, when we can use a different group now. So why this is very important? So such kind of moiety you have to synthesize over here, and that are useful for different biological active compounds. And that's why such kind of example I have taken since from beginning in the retrosynthesis, because we have to directly use in the industries, because this is very important chapter as far as the industry and research is concerned. Okay, so here when we can see the propanolol, again it is a beta blocker which can reduces blood pressure. So again, if you can observe, there are two functional groups are there. If we consider this 1 and 2, there is also 1 2, and here is also 1 2. And we know that we have already discussed that when there are such kind of multifunctional compounds are there, then we have to disconnect the side chain first, not at the center. And that's why there are two possible 1 2 difunctionalized positions are there to disconnect. And we know that amines are more reactive, so that can be disconnected first. So in the guideline of the retrosynthesis, we have already observed that the disconnection for the more reactive is preferred. So in this case, when we can disconnect this, what will happen? This carbon get always which charge, positive or negative? There is always positive charge, and
Positive.
here we can get, if we know that this is
Positive
positive
charge.
charge, always we can get corresponding epoxide, so we can get epoxide. And nitrogen is negative charge, and they can get NH2, secondary amine is there, right? So this is secondary amine, and here there is a again once it can form epoxide, then it is a beta naphthol, so we can disconnect this one. Again, this is a very good precursor, and we can get beta naphthol, and here we can get epichlorohydrin. So this epichlorohydrin is easily available. So lone pair of electron in pairs of base, we can carry out such kind of reaction. So what is the starting material now? Beta naphthalene is easily available. Epichlorohydrin is also easily available in pairs of base. When it can carry out reaction, we can get corresponding epoxide. And this epoxide is when it react with any kind of nucleophile. Here we can use the amine, that is isopropylamine is there. Then it carried out the formation of product is there. So again, it can be attacked towards the less uprooted side instead of hindered side, and that's why we can get such kind of product. So did you understand this disconnection? They are very important, and always you use such kind of disconnection or such kind of compounds in your project. So such kind of reaction always we have to include in your project. Now this is also one more important drug intermediate. Everyone know that This is a which kind of functional group? Imidazole. Okay. So this is carbon number one, this is carbon number two. So it is 1 2 disconnected. So we can disconnect over here. And once such kind of acetone is there, and this is the benzimidazole. And as it is a nucleophile, so always we have to use such kind of corresponding Cl. So here we can get corresponding now positive charge, and here we can get negative charge, right? So positive charge on the methyl always corresponds to corresponding halogen, and that's why we can get such kind of reagent over here, and corresponding imidazole is there. Now, so that is also very simple molecule in which we have observed this is carbon number one, this is carbon number two, and this is corresponding allylic group, and this is hydroxyl group. So that is nothing but there are again 1 2 difunctionalized compounds are there, right? Then how to disconnect? If we see the function group and corresponding position, then there is alcohol, this is allele, and this is ether. So there are three different kind of function groups are there, and this is CX center of the molecule. Now we have to observe how the which kind of disconnection is favorable, either this or this. So first we have to identify the function group and pattern. They are attached to the central carbon atom. Now there are two possibilities that we have to disconnect, either A or either B. So what will happen when we can disconnect this? A, anyone? What is the product when we can disconnect by using A disconnection?
Diol form nano.
1 2 diol is there, right? And it is obtained from alkene.
Hmm.
So that is nothing but styrene. Styrene is the starting molecule. Okay. And in this case, to allele group, what is the charge on there? Positive, right? And here we can get bromine.
Yes.
So whether it is a very simple reaction, yes or no? I think no one is actually interact or discuss during this point, because this you have to think like that. Otherwise, it is very easy to directly take, and this is the disconnection, and this is the synthesis. That is very easy. But my approach is that you have to think like that. Why? And what will happen? At which position we can disconnect? And when we can disconnect at that position, what is the probable product? What is the problem when we can synthesize that one? So you have to think like that, and that's why you are a master. So when you will take the degree of MSc, always your thinking is somewhat different than the regular one, and that's why even though this is our 10th lecture, mostly the other chapters of other faculty members, they have almost concluded, or they are coming to the ending the topic, but still we are going on, because that is a very important part, and this is required when you will join to higher education, research, as well as industry. And if you have command on retrosynthesis, then you have very much demand in the industry, be remember. Okay, so when we can disconnect this one, either we can disconnect A, what is the problem that we have to observe? Okay, now when we can disconnect B. Okay, so what will happen when we can disconnect B? We can get positive charge over here, right? Yes or no? Yes. So here we can get positive charge, and that is nothing but epoxide. Directly we have observed in the previous example. And here we can get the OH. Now, by both the way we have discussed whether A and B is most preferable. So B is more preferable rather than A. Why? What is the problem when we can disconnect A? Because when we can disconnect over here, there are two hydroxyl group are there, and there is competitive reaction. We remember, and that's why we can prefer B. And in this case, when we can prefer B disconnection, then there is possibility that we can get allyl oxide O minus and get corresponding positive charge, so it can form epoxide and allyl alcohol is there. So in presence of base, epoxide react with allyl alcohol because lone pair electron are available, so it can donate over here and we can get corresponding target molecule. So my question is,
Target
why
one.
not A? Because there are two hydroxyl groups are there. Even though disconnection is very easy, but when we can try to disconnect this at position A, there is formation of 1,2-diol that already you have told me. But one, no, this is also very easy. So there is possible that allyl bromide is there, 1,2-diol is there, which is obtained from corresponding styrene. But when we can obtain such kind of intermediate, because this is available, you can also prepare this one. But how the reaction is carried out? Because there are two hydroxyl group are there, so there is competitive reaction. So two nucleophilic alcohol are there. So there is chemoselectivity problem. And as we have already told that you should avoid the chemoselectivity problem. If there is any kind of regioselectivity or stereoselectivity problem is there, you have to always avoid that one.
Oh, molecule.
So such kind of alkylation is not takes place on either side. What will happen when we can add allyl bromide? It react with both hydroxyl group. Yes or no? If such kind of group is
Yes, sir.
present on, if such kind of group is present on here also, then it is possible. Okay. So did you understand why A is not preferred? Yes or no?
Yes.
Okay. Now we can move such kind
Yes,
of
sir.
different function group. Okay. So here we can use such kind of only difference in that instead of hydroxyl there is nitrogen is there. Okay. Now in this case there are two different function group are there. One is nitrogen, hydroxyl and oxygen, right? So in previous case we have just observed such kind of example that why in that case also we have preferred disconnection of side chain and along with these two which we have to disconnect. So such kind of example just we have seen. So we can carry out such kind of reaction over here. But when my focus is why we cannot disconnect A position in that also. So in this case, if you observe, when we can disconnect A rather than B, so we prefer B because when we can disconnect this, because there are also one two, because we have already told that there is a two 1,2 difunctionalized positions are there, and out of that we can prefer this one because there is more reactive nitrogen is there. When we can disconnect A, what will happen? We can get corresponding beta naphthol, and there is positive charge over here, so it can get corresponding synthon, and always lone pair of electron of oxygen attack over here, we can get epoxide. Now the question is arises, phenoxide is good nucleophile, but there is problem because there is nitrogen and hydroxyl is there. So two nucleophile are present in a molecule, then there is alkylation is takes place, because this is also attack over here and this is also attack over here, and that's why such kind of reaction is competitive reaction, so we can get number of products. So to avoid such kind of chemoselectivity, always prefer the B that we already discussed. Okay, did you understand why in the previous example we can we cannot prefer A? Now we can move to one more example, that is intermediate towards the moxidazole, that is anti parasitic. So if you observe, this is 1 and 2. So there are two function groups. So this is 1 and 2. If you consider over here, here is also 1 and 2. So that is nothing but like previous example, there are two 1,2 difunctionalized positions are there. So that is nothing but when there are number of positions are there, you have to prefer identify the function group, then we can check the pattern, and then we can check whether the CX and 212 difunctional disconnections are there. Now, so if you again see similar to the previous example, there is position A, B, C, and D. So how many way we can disconnect? There are four different ways are there. Now, again we can not disconnect A, even though it is a terminal NS2 is there. So what will happen when we can disconnect this? Anyone can guess now? Because previous two example we have discussed. So when we can disconnect this, there is NH2 and here also nitrogen. Whether the reaction is takes place between these two?
No.
Yes or no?
No,
No.
sir.
And that's
No.
why even though there
Nitrogen.
is A
No, sir.
side chain is there, we cannot obtain. Now we can see B and C. So in the B and C, what will happen? When we can, this is carbonyl group is there, so it is preferable to disconnect this. We can get NH and OH. Now if you observe this, then there is possibility that we can remove this one, because there is electron withdrawing on both the sides there. That is chloride or ethoxy group is there. Then it is possible, and then we can disconnect this position. So we can get NH2, NH2. So how this now, out of these two, which we can break? E. Why? Because here we can get epoxide. Always prefer epoxide formation when hydroxyl is there. So epoxide is there. Now, once we can form epoxide, what is the name of this?
Hydrogen.
Yes.
Hydrogen.
So it is hydrogen. Hydrogen is available, and that's why we cannot break A. We remember, because it is available with us. Now, once we can form this, we can remove this, because epoxide is obtained from epoxy chloride. So it is also available. So we can disconnect this bond. At initial stage, we cannot disconnect this. We remember, because once we can disconnect this, it required halogen. So the path is not correct one, and that's why we can prefer such kind of epichlorohydrin. What is the name of this? Anyone?
Morpholine.
Morpholine, right? So this is morpholine,
Morpholine.
and morpholine is react with epichlorohydrin. So if we see the disconnection overall, we can prefer BC, and we can carry out such kind of intermediate. Then again further disconnection, we can get epichloro morpholine. We can disconnect this, we can get starting mode. So that is nothing but the morpholine. How the reaction is carried out? Morpholine react with epichlorohydrin, we can obtain this product. Now this is the very good attack electron deficient position. So the hydrogen hydrate in presence of base, when it react with morpholine derivative, we have obtained such kind of intermediate. And then this react with such kind of group which having electron withdrawing, either similar or different, then we can get such kind. Mostly we can prefer a symmetric one, so only one product is always
Yes.
obtained. Okay, so here lone pair of electron, which lone pair of electron are commonly used? Hydroxyl. They can form bond over here to get corresponding moiety, and then lone pair of electron of the nitrogen attack over here, and we can get the target molecule. So did you understand? This is a very important example. Yes or no?
Yes, sir.
Okay, now we can prefer one more example, and probably we will stop over here after this example, because we have a function at 11:30 and everyone should be joined. So if you observe, this is 1,2-diol, right? And we obtain this that is the hydroxylation functional group bitter conversion. We can prefer alkene, that we already say. So once alkene is formed, we know that we have to prefer to break this bond, and that give the preference to the Wittig reaction, and that's why we can always use aldehyde and Wittig. So Wittig is obtained from corresponding triphenyl phosphine, alkyl halide in presence of base, right? So there is no need to give in detail, but everyone know now Wittig reaction. Yes or no?
Yes, sir.
Yes,
हा,
yes.
कारण आपण ऑलरेडी पाहिलेली आहे, त्यामुळे पुढचं डिस्कनेक्शन तुमच्या लक्षात आलं पाहिजे, म्हणजे तुम्हाला इमॅजिनेशन तुमची एवढंच आता चांगलं झालं पाहिजे, कारण आपण एवढे प्रचंड एक्झाम्पल पाहिलेले आहेत ह्याच्यामध्ये, आणि तुमच्या लक्षात आलं असेल की हे तयार करण्याकरता किती वेळ द्यावा लागतो. तर ते करत असताना तुम्ही थोडंसं आता तुमचं इमॅजिनेशन पॉवर वाढवली पाहिजे, की विटिक म्हणल्यानंतर त्याचा रिएजंट, त्याचं स्टार्टिंग मॉलिक्यूल आणि साधारणतः कशी रिएक्शन होते हे तुम्हाला माहिती असलं पाहिजे. कारण हे मेकॅनिझम्स तुम्हाला जर माहिती असेल तर रेट्रोला उपयोग होतो. अन्यथा प्रत्येक गोष्ट जर पहिल्यापासून सांगायची म्हणलं तर मग थोडासा वेळ जाईल. ठीक आहे, आता हे तुम्हाला माहिती आहे आणि त्यामुळे हे डिस्कनेक्शन तुम्ही सांगू शकता. सो आता ह्या ठिकाणी आपण व्हाय वी कॅनॉट disconnect the carbon carbon normal position. So we required natural even synthon and umpolang d1 is necessary. So we know that the very useful disconnection is there, that is umpolang, and this is the transcolizer phenaglycodol. So if you see this is the phenaglycodol. It is a very important drugs, that is transcolizer is there. If you observe, there is tertiary alcohol are there, and there are two alkyl groups are there. They may be same kind over here, and we can prefer corresponding Grignard reagent over here double to the ester, and then we can carry out one two disconnection and we can get corresponding compound. So in this case, always we have to disconnect this one carbon is there. So we have to disconnect over here, and that corresponds to ester. Now, if you observe again, there is one position is there. So at position, this is one. So we can disconnect two like groups are there that prefers to Grignard reagent, and ester is there to obtain corresponding tertiary alcohol. And if you observe this, there is also one two disconnection, one difunctionalized compound, and it is obtained from acid. Everyone know that acid is obtained from cyanide. Did you understand? Yes or no? Yes. Okay. Now, when we can disconnect this, we can get corresponding ketone and cyanogenesis. So it is very simple Friedel-Crafts acylation reaction of chlorobenzene, and then rest is very simple. So that is nothing but initially what is the your starting material? Chlorobenzene. Chlorobenzene undergo acylation, we can get corresponding astrophenone, that is parachloroastrophenone is there. Then it react with sodium cyanide, and in presence of alcohol we can get corresponding OH and COAT. So in presence of acid, cyanide is there. This is then undergo hydrolysis followed by ethanol. We can get corresponding ester, and then we can add Grignard reagent excess. We can get corresponding target molecule. So did you understand this? Yes or no?
Yes, sir.
Okay. So just we will stop over here. I think. So one more example is there, but it required more time. So we can better way to stop over here. And next lecture we will see this one. But if we see again, if you see the number is very less, why? Students are just 33. We have 39 and one have not taken admission. Na? So 38 are there, na? Or all are taking the admission? I think one have any problem, na? Out of three. So be remember only 33 is there. So we have to check the name those who are not present to the lecture. Okay. So we will stop over here, and on
Okay.
next lecture we will see the rest of the exam, because there are so many example in 1-2 position are there. So we cannot go continue. But after this lecture, probably on next we will see that one. So we require more lecture. Be remember, it is not complete within 15 lecture that I have already told to the very first lecture. And definitely no, it is very easy, because once you know the 1 2 1 3, then rest of the things are very easy to remember, and that's why that part we will going very easy. And then the heterocyclic compounds. Okay, so we'll stop over here. On next lecture we will see if the number is more than 33. Ankita, please send the screenshot.
Yes, sir.